Hello students, welcome to Learner's Planet, Theory Session 4 of Periodic Classification of Elements. So till now we discussed the classification attempts by Dobereiner, by Newland, by Mendeleev and by Moseley. So the modern periodic table which we are using, or the long form of the periodic table, what it is based on the electronic configuration of elements. That is, the elements are arranged according to their increasing atomic numbers as well as their configuration, and this was given by Bohr. So what is Bohr's law, or the modern periodic law? That the physical and the chemical properties of elements are the periodic functions of their electronic configurations. Okay, now let's see what all the I also told you about the periods and the groups in the periodic table, and let's see what all periods are present in the modern periodic table. So let's start our discussion, that is about the periods. And what is the students? Periods, there are 7 horizontal rows in modern periodic table, and these horizontal rows are called what? Periods. The number of shells present in an atom determines its period. What does it mean? Say, if I am writing sodium, this is the simplest one, so I start with sodium, or I'll start with a bit complex one, that is, let's start with aluminium. Now aluminium, the atomic number is 13. How can I arrange the electrons in this, or what is the electronic configuration? It is 2, 8 and 3. So how many shells would be there, students? There would be 3 shells. So in which period it will come? It will come in 3rd period. Likewise, if I am taking chlorine, or let's take up fluorine, the atomic number is 9. What would be its electronic configuration? It should be 2 and 7. And this is your fluorine. So how many shells are there? There are 2 shells. So in which period it belongs? It belongs to 2nd period. So likewise, or vice versa is true. That is, if you know the period number, you can tell in which how many shells would be there. Say if I say that your potassium belongs to 4th period. So how many shells would be there? There would be 4 shells. Now in this case, each period begins with an alkali metal on the left and ends with a noble gas, except the first period which begins with non-metal hydrogen. Say, if I am writing the 2nd period, so what is the first element of the 2nd period? It is sodium, right? Then after that, what will be coming? Magnesium. Then on the right hand side is what? Aluminium. Then comes what? Silicon. Then is phosphorus. Then is sulfur. Then is chlorine. And there is what? The noble gas. So it would be argon. So every period is starting with an alkali metal. And what is this alkali metal, students? It is sodium. Okay, and it ends with a noble gas. So for the 3rd period, what is the first element? Sodium, that is alkali metal, and argon, which is a noble gas. So this is the case with every period, but not with the first one, because your first period starts with hydrogen, which is a non-metal and a gas, and it ends with helium. Okay, helium is a noble gas. Not an issue with this. But what is the problem here is hydrogen. It is not an alkali metal. It is a gas. It is a non-metal. So this is about the periods. Now let's take up this in details. This is a repetition of the first one. Description of periods of periodic table. The first period contains only two elements. Atomic numbers 1 and 2. What are these elements? Hydrogen and helium. And instead of an alkali metal. So there is no alkali metal in the first period, first group. So if I have to write here, it is this side. I'll write the first period. And here the first group. And what is it here, students? It is hydrogen. And in the 8th group or the 0 group is what? Or in the last is the helium. So it consists of only two elements. It consists of helium. Now what are the atomic numbers? It is 1 and 2. So what will be their configuration, students? It would be 1 here. If I write the electronic configuration, and here it would be 2. That's it. That is, it is having a nucleus at the center. There is a nucleus at the center, and there is one shell with how many electrons? Single electron. And here is one shell with how many electrons? 2 electrons. Okay, so it begins with hydrogen and ends with helium, which is a rare gas or a noble gas, and it is the shortest period. This is also called as what? Noble gas. And it is the shortest period. Let's take up the second period. The second period is also a short period consisting of 8 elements, which is lithium to neon with atomic numbers 3 to 10. The elements in the second period are known as bridge elements. Then let's see what are the elements here. So I'll write the elements present in the second period. It is second period. What are the elements? These are lithium, beryllium, then is boron. Then what will be there? It would be carbon. Then there would be nitrogen, there would be oxygen, and there would be halogen. And finally there would be neon. So what are the atomic numbers here? It would be 3, 4, 5, 6, 7, 8, 9, 10. Now these are called as bridge elements. Why they are bridge elements? Because of the diagonal relationships. These are called as bridge elements. That is, lithium has got similar properties to the next element here, that is magnesium. Beryllium has got the similar properties to the next element in this group, that is aluminium. Boron has got the similar properties to silicon. Carbon has a similar property to phosphorus. So this is called as what? Diagonal relationship. That is, they are diagonally similar in their chemical properties. So these are also known as bridge elements. Now let's take up the third period here. What are the third period elements? The third period is also short period having 8 elements from sodium to argon with atomic numbers 11 to 18. Elements of the third period are called typical or representative elements. Why they are called as representative elements? Because their property resembles, or their properties or these elements represent their group. Their properties is the property which is present in every element of that group. the first element because of the small size. It has got the elements in the second period because of the small size, they show some anomalous behavior. But the element in the third period has got the property which is present in all the elements of that group. Say for example, I'll tell you why these are called as representative elements. If I take the very first group, that is your lithium, sodium, first is your hydrogen, okay? Lithium, sodium, potassium, rubidium and cesium. Now in this case what happens, students, that this lithium is the first element. Now this is very small in size. So as it is small in size, it shows what? Anomalous behavior. That is, its properties are different from the elements of this group. But your sodium, the property of the sodium is also present in potassium, rubidium and cesium. This doesn't show any anomaly. This is not showing anomaly. So elements of the third period are called as representative elements. Elements of the second period show anomalous behavior. That is, a behavior different from the other elements of the group. Now moving to I'll write the elements present in the third period. So starting with sodium, then would be what? Magnesium, then would be aluminium, then would be silicon, then what are the elements there? Phosphorus, then is oxygen, then is chlorine and then is argon. So these are also what? These are short period. Now moving to the fourth period, students, what it is? The fourth period is a long period consisting of 18 elements, starting from potassium to krypton, with the atomic numbers 19 to 36. Now what are these elements? I'll not write all the 18 elements. I'll only tell you about the metals and the non-metals here. Say if I'm starting with potassium, the next element here is calcium, then is gallium, then is germanium, then is selenium. I missed one. Arsenic I missed out. So I'll write arsenic here, arsenic, then is selenium, then there will be halogens, so it would be bromine and there would be krypton. But in between calcium to gallium, there are what? There are transition elements. So in between calcium to gallium, there are transition elements. Okay? Now what are they? They are scandium, titanium, then vanadium, then is chromium, manganese, there is manganese, then there is iron, then there is nickel, then there is cobalt, then there is your, what is, are they 10? 1, 2, 3, 4, 5, 6, 7, 8. Ninth will be copper, silver, gold, and then there is zinc. So students, in the fourth period, there is potassium and calcium, which are what? Which are metals. And gallium till krypton, they are what? Non-metals. And in between calcium and gallium, there are transition elements which show the properties between metals and the non-metals. So your scandium is 21, this is 22, 23, 24, 25, 26, 27, 28, 29 and 30. So these are what? These are transition elements. Now altogether, how many elements are there in this? There are 18 elements. So what is this, students? It is a long period. In the fourth period, there are two types of elements found, rather three types of elements found. We can say two types. One is the normal element and the transition element. Now let's pick up our fifth period. What all are the things here? The fifth period is also a long period consisting of 18 elements, and it is rubidium to xenon with atomic numbers 37 to 54. So if I write it again, so it is rubidium, strontium. Then this side would be indium, tin, antimony, selenium, iodine, and the last element is xenon, and it starts with the atomic number 37 and ends at 54. So these are what? These are again the metals, and these are the non-metals. Now in between what? In between this, I'll write the atomic numbers also 38. Now in between there are 10 elements which are what? Transition elements. So this would be 10, this would be 49, 50, 51, 52, 53 and 54. So in between whatever elements are there, they are transition elements. So I'll write it here as the transition elements. Now I'm not going to confuse you telling their names also. Elements. Now they are between 39 till 48. So these are your elements of the fourth period, and again there are how many normal elements, students? There are 8 normal and 10 transition elements. 8, 1, 2, 3, 4, 5, 6, 7, 8, and in between there are 10 transition elements. Now let's move to our fifth period. So this also contains how many elements? 18. These all are very, very important. That is why I am telling you this thing in detail. Don't forget how many elements are in which period and what all elements are present there. Now the sixth period is a very long period consisting of 32 elements, and it starts with cesium, ends at radon with the atomic numbers 55 to 86. Now in the students, what happens that in the group 3b of this period there is a set of elements with atomic numbers 57 to 71. There is another set of elements, there is another 14 elements called as lanthanides, and that is between lanthanum to lutetium. These are 14 elements which are known as lanthanides. So the period has 10 transition elements and 14 elements in the lanthanide series. So there is 8 normal elements, 10 transition elements, and within the transition series there are 14 lanthanide elements. So altogether there are 32 elements, and it is a very, very long period. Let's take up the seventh period, students. The seventh period is an incomplete period containing 23 elements. What are these? These are from francium, meitarium. We can pronounce it as meitarium and silent, with atomic numbers 87 to 109. Again, in the group 3b of this period, there is a set of elements with atomic numbers 89 to 103. And what are these? These are actinium, and it begins from thorium till lawrencium. And there is beginning with, I think it should be thorium or actinium. This series begins with actinium, but actinium is not an actinide. The actinide is thorium here. It begins with actinium. Now the elements are known as actinides. So this is all about the periods and the groups in the periodic table. Now let's take up their properties. Now let's see the characteristics of periods in the long form of periodic table. We will discuss the following characteristics while moving from left to right horizontally in a period. So every time whenever you study the periodic table, we either take the characteristics from left to right in the period or top to bottom in a group. We'll study valence electrons of the elements, valency of the elements, atomic radius of the atoms, metallic and non-metallic character, reactivity of the elements, and nature of oxides of the elements. So students, I'll take up this property one by one and I'll try to explain this. Let's take up its first property, valence electrons. Now what are valence electrons? These are the electrons in the outermost shell of the element. Say, if I am talking of again say potassium here, or I am talking of calcium here, the atomic number of calcium is 20. And what is its electronic configuration? It is 2, 8, 8 and 2. So how many electrons are there in the valence shell of this atom? There are 2 electrons in the valence shell. The number of electron shells, that is the number of shells around the nucleus, corresponds to the period to which the element belongs. The number of electron shells means there are number of shells. The number of shells we can say, we should not put electron here. The number of shells around the nucleus corresponds to the period to which the element belongs. The number of electrons in the valence shell corresponds to the group number of the element. We'll see how it. The number of electrons in the valence shell increases from left to right in the period. Now let's discuss how it goes on. For example, first element in a given period will have 1 electron in its valence shell, and the last element in the same period will have 8 electrons. For example, I'll take again the example of sodium only, because I think that's the simplest one. Or let's take the lithium one. Lithium, it has got 1 electron in its valence shell. Then beryllium, it has 2. Then boron, 3. Then carbon, 4. 5, that is nitrogen, oxygen, 6, then is fluorine in the valence shell, 7, and what is the next one? Neon in the valence shell is 8. So the first element has got how many electrons? 1, whereas the last element has the 8. But here again it's an exception, students. In the first period, the first element, that is hydrogen, has 1 electron, and the last element, that is helium, has 2 electrons in the valence shell. This is an exception. It is saying that the first element has 1 electron and the last element has the 8 electrons. But the exception here is hydrogen and helium. Let's see this table. First, this table shows the electronic configuration of first, second and third periods. So this is first period. First period, what all are the elements? Hydrogen and helium. What is their atomic number here? It is 1 and 2. Now let's take up its electronic configuration. So what is its electronic configuration? K shell. It's 1. In the L shell, there is no electron, whereas helium, in the K shell, there are 2 electrons, and in the L shell, there are no electrons. Now let's check out its valence electrons. So how many valence electrons are there? 1 and 2. Now taking up the second period elements, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. These are the symbols of these elements. You must be knowing this, I suppose, the symbols. We have done complete chemistry now of 10th standard. So you must be aware of these symbols now. So what are the atomic numbers? Lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9 and neon 10. Now let's check out its electronic configuration. So it is 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 2 7 and 2 8. That is, in the first element there is 1 electron in its valence shell, whereas in the last element there are 8 electrons in the valence shell. So the valence electrons are, students, 1, 2, 3, 4, 5, 6, 7 and 8. Let's take up the third period. The third period elements are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Let's take up its atomic numbers and their configurations. So it comes out to be 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17 and argon 18. And we can write down its configuration, that is in the K, L and M shell. Here also we will find out that the number of valence electrons are 1, 2, 3, 4, 5, 6, 7 and 8. So this is how the valence electrons vary along the periods. And the electrons are increasing in the same shell. Look here, it is like KLM shell. In the M shell only there was 1 electron. In the M shell only there was 2 electron. In the M shell only there became 3. In the M shell only there became 4. And in the M shell only there became 5. So likewise, where are the electrons increasing along the period? So the electrons along the period are increasing in the same shell. So now this is the way how valence electrons are moving on. Now let's take up what is valency. What is valency? Valency of the elements as one moves from left to right in the period. It should be in a period, the valency of element with respect to hydrogen increases from 1 to 4 and then falls to 1 and then again it falls to 1. Let's see how it increases. See this. Elements of the second period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So what are their atomic numbers? 3, 4, 5, 6, 7, 8, 9, 10. Their configuration 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. It is increasing. What it is doing? Look here. It is increasing from 1 to 4. There is still carbon. Then it is decreasing 3, 2, 1 and 0. What happens to the valency, students? It increases from 1 to 4 along the period and then again it decreases to 1. What is the valency of carbon? It is 4. But valency of nitrogen is 3. How it came? So when in an octet or the outermost shell, that is of nitrogen, can accommodate how many electrons? 8. Now how many are present? That your nitrogen can accommodate 8 electrons in the valence shell. How? Then it will attain its noble gas configuration. But nitrogen actually has how many electrons in its valence shell? 5. So nitrogen has how many electrons? Is 5. So what it will do? Can it lose 5 electrons? No. It cannot lose. So what it does is that it gains 3 electrons. So its valency becomes what? 8 minus 5, that is equal to 3. Likewise of oxygen, its valency becomes what? It becomes 2. 8 minus 6, that is 2. Fluorine, it becomes 1, that is 8 minus 7. That is 7 electrons in the valence shell. And 0 group, 8 minus 8. I'll write the formula here correctly, that is BH3, CH4, NH3. The numbers which are written here will be confusing you that what are these numbers. So H2, it is what? 0. These are the valencies. So students, we have discussed about the valence shell as well as the valency, and this valency thing is very important. You know, we did this in writing the chemical formulas. So from here this valency comes. Now in our next session, students, we will be discussing about the properties of the atoms, like elements, like their atomic radius and their gradation along the period. What happens to the atomic radius along the period? So just go through the periodic table once, and I recommend you from right now start remembering or mugging up the elements in the periodic table, because it would be required in your 11th as well as in your 12th. So daily, if you do one period, in 7 days you'll be through with the periodic table, and then there will be no need for you to just mug up their atomic numbers, because you know it's very difficult to mug up atomic numbers rather than elements and their positions. So start doing that. And thank you very much for listening patiently.